Okay, welcome back. In this video, I think I solved the problem that I had in the last video about not being able to compile my program. I think it's all solved. What I needed to do, the way I set it up, I set up multiple targets in my make file and so on. I try to do things a little bit more complicated than putting just a simple single executable in each project. So I had to do something slightly different. What I had to do was I had to recompile. So I had to build this. Okay, there it goes. I had to compile this. So this is a little bit different from probably what you're using, but sort of works for me sometimes. All right, now got that done. I made a new version with the changes all compiled in, and then I run this as a local C++ application. Chances are you don't have to do all of this, and if you use the wizard to set up a hello world program and then add in this code, you should be fine. You shouldn't see any of these problems that I see. Okay. Now it runs. It says starting simple variables program. That's what I put in here in the cout. Then I declare two variables, int x and int y. X I initialized to 10, and sure enough it says x is 10. And over here I did not initialize y, and it came up with some value. Okay, just so it happens to be the largest positive short int y. It could be different every time you run this. Run this 2 times, you might get completely different values. It's possible. I'm guessing if I run this again, I'll see the same value, maybe something different. Let's try it. Same thing. Okay. So the main thing to take away from this is that variables in C++ are not initialized to 0. In Java, if you've used Java, if you're coming from a Java background, probably used to seeing all your variables. You don't have to initialize them. They're always initialized by default to 0. So you cannot rely on this in C++. This can save you a lot of time if you initialize all your variables. Okay, so the way to assign values is through the assignment statement. The basic rule for how assignment statements work, and you might say, well, these assignment statements are so simple, you shouldn't have to even really think about them. Well, actually you do. It turns out C++ does things a little differently, and at first it'll look a lot like Java statements. But you will see situations where the way C++ works is quite different from Java. For this first few weeks, there probably will be no difference. Okay. So on the left-hand side of an assignment is what's called an L value, and you might see every once in a while you might see error messages saying L value is bad or something like that. And on the right-hand side of the assignment is R values, which is the right side of the assignment statement. So here are the rules. L values must be variables, the name of a variable, basically saying where something should be stored. The R value can be any expression, and an expression can be as simple as just a literal constant like 0, or a string like hello in double quotes, or it can be a simple variable like I. So R value can just be a simple variable, or it can be something more complicated like an arithmetic expression or a Boolean expression or a floating point expression. Any of those would be valid R values. Of course, if you're using floating point stuff here, the results should agree with the type on the left-hand side. Okay, so this is an example. Distance, we don't know what type it is assigned the value of this expression rate times time. And we don't know, in this particular case, we don't know if this will work because we don't know the types of rate and time and so on. But assuming these are all ints or all floats, this should be fine. So once again, on the left hand side, what you essentially have is an address where you want to store things. So this is always true. Java, C++, C, C#. The left hand side is always something, some place where you want to store something, usually the name of a variable. And on the right hand side is a value. So whatever this is, eventually, if it's an expression, it has to evaluate to some value, and it's that value that you're going to try to store in this left hand side. Okay, so keep that simple rule in mind. You might say, oh, that's so simple, I don't even have to think about it. But in this course, we will see situations where we do not see in Java ever, where the left-hand side can actually be a method or a function. That's something we do not see in Java. And then you might say, well, how do I understand that? Well, keep this simple rule in mind. The left-hand side is always the address where we're going to store something, and the right-hand side is always a value. No matter how complex assignment statement you have, this simple rule will always hold. Left-hand side is the memory address where you're going to store something. Right-hand side is always a value that you're going to store into that location. Okay. Alright, so there are some other alternatives for assigning data. There's other assignment operators. That's what we call them in C++. There's a plus equals. So if you say count plus equals 2, that's the same as saying count is equal to count plus 2. Total minus equals discount is the same as saying total equals total minus this thing, the right-hand side of here. Bonus times equals 2 means bonus is equal to bonus times 2. Time slash equals or divide equals rush factor is equal to, this is equivalent to time is assigned the value time divided by rush factor. Change mod or remainder equals 100 is the same as saying change is equal to change mod 100. Okay, and so on. So if you have a much more complicated expression than you have in these previous cases, this is how to understand them. If you have amount times equals and without parentheses some expression, it's the same as saying amount is equal to amount times and then in parentheses the entire right hand side of this. Oops. And this works the same for all these others. Plus equals, minus equals, divide equals, mod equals. If you have a more complicated expression, it's like saying that whatever expression, whatever operator you have here, and then in parentheses, whatever's over here. Okay, so try some of these. The best way to figure these out is definitely to try some simple examples and convince yourself, well, make sure that you understand these simple assignment operators. Okay, so now let's take a look at compatibility of data assignments. Basically, types should agree. If not, they should be promotion capable. Okay. The general rule is you cannot place values of one type into a variable of another. So, of course, that's not, as you probably know in Java, you can promote. So promotion does happen in C++ too. But the general rule is, you can't mix and match types. So this is a situation where, let's say, this int var has been declared, and so it doesn't actually say here, but let's say this, just assume that this is an int. You cannot assign it the value of a double. Okay. So you can, what I should say is, you cannot expect that you get all of 2.99 into this int variable. Only the 2 goes into the int variable. So although this might work, you cannot expect all of this all of this expression, all of this literal constant in this case, to go into the int variable. Only the integral part fits, and so that's all that goes into this int variable. So while you can, in Java, actually, let me think about this. Yeah, in Java, this would give you an error message. In C, C++, you will get automatic type conversion. So that's one big difference between C++ and Java. So let's take a quick look at that. So let's say int y is equal to 2.7, let's say. Alright, save it. Remember, in C++, it's not enough just to save it. You have to recompile. Let me check if it did the right compilation. Nope, it did not. So yours might work a little easier. Mine, I have to putz with it. I have to check and make sure it does compile the right thing, and then let me see if I can run it. And sure enough, it says x is 10. That's fine, and y is 2. It threw away the fractional part. So, big difference between C++ and Java. In C++, if you want this 0.7 to go into the left-hand side, you need a double here. If you don't have a double, if you have an int in this case, then the fractional part goes away. And the same thing is true for, let's say, short. You can try this. Save it. Remember, that's not enough. I have to compile it explicitly. Worked. Then I have to run it, and it says 2. And even if I use a long, there's no difference. If I use an integral type like short int long, and I have a fractional part, the fractional part disappears. Okay, let me run this, still get the same thing. If I use a double, then things are different. Alright, I did compile, and now I get the fractional part. So to repeat, you want types to match. There are things like promotion, sure, that does happen, but in addition to what you saw in Java with promotion, there is also automatic type conversion in C++, which means that if you have a double precision on the right-hand side, assign it to an int, you will get an automatic type conversion, which means you throw away the fractional part. Now this can work in many cases, but it can also introduce all kinds of very subtle bugs. Let's say you were assuming that this variable would have, for whatever reason, even though it was an int, you're assuming that it's 2.99, and you check for equality, you check int var equal 2.99, that will never be true, right? So you can get very subtle bugs if you do this. In general, you do not want to do stuff like this. You want to have, if you have a double on the right hand side, you want to make sure the type of variable that you have on the left hand side is a double. Okay. So literal constants are things like 2 minus 2 plus 2, that would be literal ints. 5.75 would be a literal double constant. Something in double quotes would always be a string. Something in single quotes would be a character. That's pretty much just like Java. And these are considered constants that you cannot change in a program. These are literal constants. Okay.